Alright, okay, we're going to introduce you the integration of trigonometric function. Alright, as you learned before, as you differentiate sine x, right, sine x, so you are getting cos x, right, you're getting cos x. So if you differentiate cos x, you are getting negative sine x. So if you're differentiating tangent x, you are getting secant square x, right? So I just talked about these three, okay, basic integration. So there are three more. So but in this video, I'm going to talk about these three types. So if I integrate cos, right, as you know that it's a reverse process. Integrate is a reverse process for differentiation. So as you differentiate sine, you're getting cos. Of course, you integrate cos, you are getting sine x plus c, right? So why there is a plus c here, you should know, right? Because differentiate sine x plus 2 plus 1 or anything, you're getting cos x, right? So when you reverse, there are many possibilities. There is a constant here, right? So then if I integrate sine x, so because of differentiating cos x, you're getting negative sine x. Definitely when you integrate the sine x, you are getting the negative cos x. Alright, I'm not going to go detail, I'm not going detail, so I just tell you that the formula, right? So it's like integrating for the secant square of x. So I will get back tangent x, right? Because differentiating tangent x is secant square, right? Okay, I will give you some examples here. So this is a basic formula that you need to remember. Integrate cos, you're getting sine. Integrate sine, you're getting negative cos. Integrate secant square, you're getting tangent x. Okay, let's move on with some examples. Alright, okay, let's look at this. Integrating sine. So at the first part of this video, I introduced you integrate sine. Integrate sine, you were getting negative cos. You have to remember the formula. Integrate sine, you're getting negative cos, right? Negative cos. So sine become negative cos and 2x. You just write back the 2x. But it's slightly different because just now it's a basic. So if there is a coefficient of x, the coefficient of x is 2, then you're going to divide by 2. That's the technique here. So where you're getting negative 1 over 2 cos 2x plus c. Very simple. The formula is the same. Integrate sine, you are getting negative cos. Integrate cos, you are getting sine. Integrate secant square, you are getting tangent. But you also have to consider the coefficient of the x, right? If 2, you divide by 2. Okay, let's look at this case also. Alright, so it's the same thing here. So integrate cos. Integrate cos, you know, is sine x, right? Sine x. And integrate sine 2x is exactly the same. So I just integrate sine, I'm getting negative cos 2x over with 2 plus c. So I have sine x plus with 1 over 2 cos 2x plus c. Alright, I will go more examples so that you can see how to apply the formula. Alright, okay. Let's look at these two examples. So, simple. So you have, remember the formula, right? You have integrate sine, integrate cos, integrate secant square. So I've taken the 3 out. I have integrate secant square 2x minus 3 dx. So as you know that integrate, because you know differentiate tangent, you're getting secant square, right? So it definitely, when you reverse the process, you integrate secant square, you get back the tangent, right? You get back the tangent, means that secant square integrate, you're getting tangent 2x minus 3. But I always tell you that if you see there is this is a linear, right? It's a linear. So if you look, there is a coefficient of x here, which is 2. So I'm going to divide this by 2, okay? Plus c. So I was getting 3 over 2 tangent 2x minus 3 plus c. Right? So without overcomplicating the formula, I just teach you a very simple formula. Integrate secant square, you're getting tangent. Integrate sine, you're getting negative cos. Integrate secant square, you're getting tangent. Integrate cos, you're getting sine. Alright? You just remember that. Okay? Remember that. So integrating sine, you know, you are getting negative cos. That's all you need to remember, right? That's all you need to remember. Integrate sine, you're getting negative cos. And you copy back what you have here, and you see there is a coefficient of x here, which is negative 2, right? So you just divide by negative 2, alright? As simple as that. So integrate second square, you know the formula of integrate second square, you're getting tangent. So tangent 4x, just you must remember there is a 4 here, so you divide by 4 plus c. So if you don't believe me, you can try to differentiate this again. You will get back what is inside here. That's the powerful of integration. So then you have 1 over 2 cos 4 minus 2x minus with 1 over 4 tangent 4x plus c, right? 1 over 2 cos 4 minus 2x minus with 1 over 4 tangent 4x plus c. Okay, let's go for more examples. Right, okay, let's look at these examples. So you can try first, okay, before you look at it. So you must remember that 1 over cos square. 1 over cos square is second square 3x. So for this, you cannot integrate yet. You cannot integrate this, as if you integrate this separately, you cannot say, oh, integrate sine, getting negative cos. I getting cos, I getting sine. No, this is a product. Can you see that? This is a product. So then we have to apply some formula to make it, because we only have integrate sine, cos, and second square. So now there is a sine cos here, but I see this as the angle identical, 2x and 2x, right? So I try to apply double angle formula, right? Means that when you study about integration of trigonometric function or the trigonometric formula, you have to remember. So for example, if I have sine 2x cos 2x, and I remember there is a formula which sine 2a equals to 2 sine a cos a. Alright, sine 2a equals to 2 sine a cos a. And now I'm going to apply this formula into this situation here, because I can see there is a sine cos here. And the most important thing is this is 2x and this is also 2x. They are identical. So what happens if I replace the a with 2x? The a with 2x. See, this is double angle formula, right? Double angle formula for sine theta. So sine 2x. This is 2x, 2x. Definitely this is 2a. 2a, it will be 2 times 2x. It will be sine 4x. Now I can convert this sine 2x cos 2x, sine 2x cos 2x to 1 over 2. Sine 2x cos 2x to 1 over 2. 1 over 2 of sine 4x. It's become a single term, right? Then only you can start using that formula, which is you're getting 1 over 2 sine 4x dx. Make sure you cannot simply apply formula. You have to see. You cannot integrate this separately, right? They are product. So you have to convert it become a single term. So now you have second square and integrate sine. You can using that formula. So integrate second square, you know, is tangent, right? Integrate second square, you get back tangent. So divide by 3. Integrate sine. Differentiate sine is cos, but integrate sine, you're getting negative cos. Negative cos 4x. Don't forget, there is a 4 here, so you have to divide by 4 plus c. So you rearrange, you're getting 1 over 3 tangent 3x negative 248. So 1 over 8 cosine 4x plus c. Alright, that's the way we have to able to using all the formula for trigonometric. So what is the formula that you learned before? The identities, the trigonometric identities, the double angle formula, compound angle formula, and factor formula, right? All that you are very familiar. So please go through all the formula before you studying the integration of trigonometric function. So okay, let's move on for more examples. Alright, okay, let's move on with these examples. For this example is also a product form. right? It's a product form where sine 4x and cos 2x. So for this to be integrate this, you need the formula for you can know that you have double angle formula, you have compound angle formula, you have factor formula, and I just directly tell you that if you look that this is sine cos, if let's say 4x, this is 4x, the angle is identical, then we apply double angle formula. But now they have different size of angle. One is 4x, one is 2x, right? So this type of cases where there is a product, we usually using the factor formula, alright? Factor formula, alright? What does I mean here is I using the formula of sine A plus with cos A. Sine A plus cos B. So if you still remember that if I have sine plus sine, alright? Sine A, okay, sorry, is sine A plus, alright, is sine A plus sine B. Sine A plus sine B. So you know that sine A plus with sine B, it will produce 2 sine A plus B over 2 cos A minus B over 2. Probably you need to go and refer to the formula about factor formula, right? Refer to factor formula. So why am I talking about factor formula in these cases here? Because the size of the angles are different, and it is a product form between sine and cos. In both are linear, alright, are linear. So I'm going to consider about factor formula, and in this case there are 4 types of factor formula. So but I introduced about this one because this is a sine and a cos. Can you see that there is a sine cos here, a product of sine cos here? So if you still remember when I talk about trigonometric factor formula in the one of the video, so I was talking that if you want to convert from product form, you cannot integrate this, right? If you have product form, you have to modify, okay? So it means that I'm going to convert it become addition form. So where I'm going to let this thing to be my P and cos to be Q, right? If you learned before, please refer to the video of factor formula, trigonometric factor formula in my channel, so then you can see what am I revising here. A is P plus Q and B will be P minus Q. Okay, why I was getting this, I have shown you in that video also. So now I'm going to use this formula because I want to convert this to this here. So this is the formula given, so I convert by this, so that is easy for me to change it to addition form. So now I can see that my P from here, this is my P and this is my Q. So it means that I know my P here, I just follow this formula, 2 sine P, my P is 4x and my Q is 2x. P is 4x, Q is 2x. Definitely here I need to convert become sine. So P plus Q. P plus Q means 4 plus 2. Alright, 4 plus 2. I have 6x plus with sine. P minus Q. This is your P, this is your Q. P minus Q. 4x minus 2x. 4x minus 2x, you have 2x. So it means that sine 4x. Now I convert here. So I just rewrite everything here, and I know that integrating sine 4x cos 2x is the same as 1 over 2. Right? Integrating 1 over 2 sine 6x plus sine 2x dx. Why am I doing this? So that I can apply the formula for integration of simple trigonometric function. Because there's addition. So I take out the 1 over 2 and I integrate sine 6x plus sine 2x dx. This is my purpose. I convert to become addition. So then I can separately integrate sine. Integrate sine. You know, integrate sine is negative cos 6x, right? Negative cos 6x. Then divided by, in front of x is 6, so you divide by 6. And integrate sine, also you're getting negative cos 2x. But this time you divide by 2 plus c. Can you see that? You need the help of factor formula here, as you cannot integrate this when they are in product form. Must remember that. So then you're getting negative 1 over 12, expand, negative 1 over 12, cos 6x, 1 over 2, negative 1 over 2, negative 1 over 4, cos 2x plus c. Alright, I have applied factor formula into this integrand here so that I can integrate. So I will give you more examples. Alright, okay. So now I list out all the factor formulas for you. So I tell you that you need to use factor formula for this because there is a product form. But sometimes the product form you have, if you have one sine and one cos, you will use double angle. But for this is a cos, and where the most important is the angle, the size of the angle is different, right? Different. So for this type of cases, we consider factor formula. So, but there are 4 types of factor formula. Which one to choose is you have to understand what you need, because you see there is a double cos here, cos multiply cos. This is the part where you have product form, right? Sine product with cos, cos product with sine, and only this formula, the third formula here, you have cos product with cos, multiply with cos. So then I have to choosing this formula, choosing this. Why? I tell you the reason, because I see there is a cos here, right? So I'm choosing this formula. Immediately after I know that this is my formula, my factor formula, I want to convert from the product form to the addition form. So I have to apply another formula where I modify this, this formula such that the cos, the A is P plus Q. Always refer, okay, please refer to the video that I'm talking about this factor formula. It will definitely help you. So cos P minus Q, right? Cos P minus Q. So which is equals to 2 cos P cos Q. Means that you always convert P. As you see A plus B over 2, that is a P. If you see A minus B over 2, then that is a Q, right? In the previous, in the lesson where I derived this formula, I'm using compound angle formula. So you can actually apply some simultaneous equation here. You can solve it and you find the value of A and B. You will get exactly A is P plus Q and B is P minus Q. Okay, so now, okay, I'm not going to talk about how to getting this formula. Now you have to know how to apply this formula. So now I have 2 cos P cos Q. So here I have 2 cos 6 cos 4. So definitely you see, I can directly transfer this to here, right? So whereas the P is 6 and the Q is 4. So means that I know that 2 cos and my P is 6x, my cos is 4x. This is product form. I can't integrate this directly, so I have to using factor formula in help me in writing in addition form. So then I have cos P plus Q, so 6 plus 4, you have 10x plus with P minus Q, 6x, P minus Q, 6x minus 4x, so you have 2x. Now you can see that 2 cos 6x, cos 4x is produced by taking cos 10x plus with cos 2x. They are actually equivalent. So which I have converted this product form into addition form, which is in the form of cos 10x plus with cos 2x dx. Right? Now you see this is not a product form, it's a single form. So you can actually rewrite this as cos 10x dx plus we integrate cos 2x dx, right? Now you can see integrating cos integrating cos, you're getting sine 10x, right? Don't forget to divide the coefficient in front of x, which is 1 over 10. And for this case also the same, 1 over 2, right? The coefficient for x is 2, so you're getting 1 over 2. And integrating cos, you're getting sine 2x plus c. As simple as that. You apply factor formula. So I have introduced you the using of some compound angle formula in solving the trigonometric function. Alright, let's go for more examples. Alright, I think that's all for this video. I'm going to discuss more about trigonometric integration of trigonometric function in the next video.